All right. For this, what we're going to have to do is, first thing, we have to understand kind of what a piecewise function is. It's in the name. It's pieces of a graph. So this is one piece of the graph, and this is a second piece of the graph. So next, whenever we actually graph these, it's going to look kind of funny. But what we're going to see is we have two whole entire graphs: negative 2x plus 1, and then y equals 5x minus 4. Two graphs. But here's the deal. This one is only used when x is less than or equal to 2. So that means if x equals negative 3, 0, 1, even 2, we're using this graph. But if x is greater than 2, meaning 2.1, 4, 100, we're using the second graph. Okay? So this really helps whenever we're starting to evaluate. So if we're looking at f of negative 4, we have to say, okay, x equals negative 4. Is that less than or equal to 2, or is that greater than 2? Well, x equals negative 4 is less than or equal to 2. So we're actually going to plug it into the first equation, negative 2x plus 1. So we have negative 2 times negative 4, which is positive 8. So that is going to give us y equals 9. Alright, then for the next one, x equals 8. Okay, so is 8 less than or equal to 2, or is x greater than 2? Well, x is greater than 2, so we're going to plug it into the second equation. So we have 5 times 8 minus 4, so that's 40 minus 4, so y equals 36. Alright, now the tricky part, x equals 2. Which one of these is true for x equals 2? Well, the second one is x is greater than 2. Well, that means anything bigger than 2, but it doesn't include 2 itself. The only one that can say x equals 2 is this first one. So we're going to plug it into this first one. Now, one thing to notice here is that we only plugged it into one equation. We can't plug it in to both. We can only plug it into one. So if x equals negative 4, we can't plug it in to the second equation. X equals 8, we can't plug it into the first equation. So we are only going to have one answer. One answer, one answer.